SwayamPrabha. Digital India. Educated India.
The next important topic in CNC is going to be miscellaneous code functions. So, miscellaneous codes these are all important from the point of view of execution. G00 command are preparatory code, they will be used for simulation, do drive simulation and see on the system whether the profile whatever is cutting is to your requirement. But when we start introducing the miscellaneous codes, these codes are going to help me while manufacturing the product. So, M00 is program stop or spindle and coolant off, we use M00 command. M01 is optional stop or a dwell cycle. M02 is end of the program. M03 is spindle move in clockwise direction. M04 in counterclockwise direction. If we want to stop the spindle, we give M05. Then for a tool change, we give M06, coolant supply on. So, it can be, this can be flood type, this can be mist type. So, we say M07, M08 for coolant supply, and for offing it, it is M09, and M13 and M14 are spindle on clockwise plus coolant on, spindle on counterclockwise plus coolant on will be M14. So, M19 is spindle stop at a specified angular position, we use M19, and M30 is program stop at end tape plus tape rewinding is M30. So, we can use these commands for executing the part in a CNC machine. So, commonly used word addresses are N code. So, N code is the sequence number used to identify each block with an NC program and provides a means by which NC command may be rapidly located. For example, N10, N20, N40. So, N is nothing but the line number. It is program line number. It is a good practice to increment each block number by 5 or 10. So, that in case if you want to do some additions, it can be easily inserted in between those lines. G codes. G codes are preparatory words used as a communication device to prepare the MCU. G codes indicate that a given control function such as G01 linear interpolation is to be requested. G codes are preparatory words. X, Y, Z codes are coordinates. Then we have F for feed rate, S for spindle speed, T for tool number, M for miscellaneous code, I, J, K code for they specify the center of R coordinates from starting. So, this is what I said, I, J, K or R command can be used. The R command can be used for a radius. If you call it on a CAN cycle, R command is used for the reference plane. So, this is a structure of a sequential block. So, you will have a sequential number, then you will have a preparatory function, then you will have here it is all written in inches. These are all in inches. So, it is x plus 1.4, y plus 1.4, z plus 1.4. So, these are the destination coordinates. I, J, K are the distance to center of circle, x axis, y axis, k axis offset, or if you do not want, you can write it in R command which talks about the radius. Then we have feed rate again in inches, spindle speed, and then we have tool number, and then miscellaneous function M02. What is a miscellaneous function? M02, end of program, often interchangeable with M30. So, you can give M02 or M30. And in this block you should understand M, when we try to write the M code, it will be almost at the last. So, you will just follow this sequence in a fixed block. So, what will happen is you will have to fix all x, y, z, all the data has to be filled in. So, this is what is the xy plane. So, now we are going to see the G16, 17, 18 planes whatever we have done. So, xy plane selection for vertical axis milling machine. So, this is the G17 code which is used on a xy plane. So, this is the xy plane selection on a horizontal axis milling machine. Please see the difference. This is xy plane for vertical axis milling machines, bottom xy plane. When I do the same thing for a horizontal axis xy plane, this comes like this. So, this is x and y G17. So, the xy plane for horizontal axis xz plane horizontal axis milling machine x and z. So, this is G18 xz plane selection for horizontal axis milling machine. So, YZ for a horizontal axis milling machine is G19. So, you see from machine to machine, horizontal to vertical axes when you do. So, you can see the planes differ. You have to define these planes. Then after defining this plane, in this plane what are all the operations to be done. So, then you can ask that to do. So, now whatever we have studied in rapid traverse, let us have a pictorial representation and understand. When the tool is being positioned at a point preparatory to a cutting motion, to save time it is moved along a straight line at rapid traverse at a fixed traverse rate which is pre-programmed into the machine's control system. Fixed traverse is the highest feed rates whatever it is. Typical feed rates are 10 to 20 meters per minute, but can be as high as 80 meters per minute. So, the syntax when we use this G00 command, we will say this is the numbering of the block. So, N0010, and then you can say whether to follow absolute scale or incremental scale, any one. Then you say G00 which is rapid traverse, and then you will define x and y and z motion. What is that? So, this will be the destination point which G00 has to, the tool will move. So, when we try to do on a turning, it can be with respect to this or with respect to the nose radius. You have to define it prior, or it can be with respect to the center of the tip or for the periphery of the tip. Depending upon the tool register whatever you have done, accordingly you change the center point. You have to look for the machine, how does they take the reference points. And suppose if they take it for this, then you have to give these points as offset. If you take it for the center, then the diameter or the radius is given as offset. When you look at G01, the tool moves along a straight line in one or two axes, that is what I said, horizontal, vertical, two axes are taper. Simultaneously at a programmed linear speed, the feed rate. So, here we follow the speed and feed rates what are defined. So, here what we have to do is we write the block N010, G90 or G91 absolute or increment, G01 command x, y, z, and we define the feed. So, you can also have the speed 1000. Okay. So, at a programmed linear speed and feed rates, the block will execute. When we talk about circular interpolation G02 or G03, it is circular interpolation. There are two formats. One is number block 01. So, then you can choose either G02 or G03. This is circular clockwise, this is circular counterclockwise, and then x, y, z, then you will have an offset in x axis, offset in y axis, offset in z axis, then you will have a feed rate. So, using the arc center. So, here the other option can be N02, same code G02 clockwise or counterclockwise, x, y, z, and then you define a radius r and a feed. So, using the arc radius. The arc center is specified by the register I, j and k. I, j and k are the x, y and z axis coordinates of the arc center with reference to the arc starting point. So, it is here, it can come up to here. So, it is I, j, and then you will have, so it will move from here to here, and this point is defined, and then you define the radius r. So, it is I and k, you have a swing like this. So, it is G03 counterclockwise, you can have I and j will be this, and then you will have a radius from the center point. So, it is I and k for a turning. So, I and k for turning. G90 absolute position command, each dimension or move is referred from a fixed point known as absolute 0 point of the part 0. The absolute 0 is usually set as a corner edge of a part or at the center of the square or round part or an existing bore. Absolute 0 is where the dimensions of the part programming are defined from. So, this is what is the absolute, this is what is the 0 0. From this point I am trying to define the xyz for this and the xyz for this. Absolute dimensions are referred from a known point on the part and can be by any point the operator chosen, such that the upper left corner center of the round part or at the existing bore. So, he can choose anywhere. So, this is the left bottom, left top, extreme corner, whatever he wants he can do, and everything will be with respect to this point we try to take the dimensions. So, here syntax n we have 0 2, then G90 for absolute, x y j are z, x y z are for their coordinates, we say a b c are for the rotation about x y z. So, this is what we designed in the absolute code. When we talk about increment, it is modal and changes the way axis motion command are interpreted. G91 makes all subsequent commands incremental, 0 floating shifts with the new position. So, this will be written like this. So, there is no difference, syntax will be almost the same. This is for x, comma y, comma z. If you want to define a, comma b, comma z, it will be like this. This is G90, this is G91. So, everything is with respect to this point, you go here, and then with respect to this point, you go to the next point. So, every point where you stop becomes a floating 0 point. This 70 and 71, it is in inches. So, it is in metric. So, this is how a syntax is. You can write it as N10 70, which is in inches. Then you call it as G90, which is in absolute scale. Then 94, 97 and M04. Let us see what is 94. It is feed rate in minute, and then 97 is spindle speed in revolutions per minute. So, we have put all those points here. So, it is one syntax you can call. G94, G97 and M04 is spindle on. So, all these things are done in one line. So, you should understand the syntax. G970 is inches absolute, then it is you can talk about inches per minute, and then this can be in RPM, and then this can be the spindle on. So, all these things can be defined in one block. So, this is absolute and increment, I am just comparing. So, N07 is the 7th line of that particular program. You have called G90, which is absolute, and then you said G01 move to this point A, which is x5 and y10. So, the next point is going to be, if I am going to move here, it is going to be next G N. So, to have a safer role, it will be N008 G90, then you will say G01 x25 y15. Okay. So, here I am just trying to play safe. You need not call at every block the previous G code whatever you have used. You need not call. If you call it, you maintain it so that you will know where you make an error. Otherwise, it is not necessary to call. The next sentence for this is for B and this is for C 009. I just say x35 y5, that is all. So, rest all it is assumed from by the modal command, it takes G90, it takes G01. So, this is what it is. So, here what we have done is with respect to absolute, with respect to a standing reference, we have noted down all these points. Now, let us do the same thing with increment. When we do with increment, this is, so your N07 which is here A. So, here what you do is you write G91, G01, you say 10 and 5 or okay. So, x is 5 and y is 10. This is point A. So, now you have already moved 10 and 5. So, when I move to point B, it is going to be, I will reduce 5, 25 minus 5 which will be 20 and this will be 15 minus 10, 5. So, incrementally it will be 20 comma 5. So, this is your B point. When you try to talk about the C point, it is going to be 35 minus 25, 35 minus 25 which is 10, right, and then y axis falls from 15 to 5. So, 5 minus 15 which is minus 10. So, this is what is written here. Now, I am sure by looking into this program you will be able to solve absolute and incremental code usage. In a program you can have several portions which is absolute and increment. Let us do one trial. So, I will now try to do a program where N007, G90, G01, X5 and Y10. The next line I am writing it as N008, X25 and Y15. The third line I can write it like this, G91, G01, okay. So, now x and y, so it has come up to 25. So, now from 25 I am going to go to 35. So, I will say x10 and y minus 10. So, I have used in the same program absolute, I have converted to incremental. So, this is possible. I have just made one block as incremental, possible. So, in your program you can write half of the program in absolute, half you can write it in increment and then once again you can write it in absolute to meet out your comfort zone. So, the cutter radius compensation, G42. So, look at it. So, this is your programmed path. So, this is your reference. So, now you are trying to take this is your programmed path. This is your programmed path. So, now your cutter is moving to the programmed path. This is your cutter, this is your diameter, right. So, now what are you trying to do is you are trying to move because the cutter diameter comes in contact and then you have to generate this profile. You have to generate this profile. So, cutter edge comes and touches the profile. So, now the cutter edge if it has to touch, the center has to be offsetted. So, now you see there is a offset path of the cutter which is generated, which is this. This is a offset path with a dash line which is there. So, this is what is created. So, this one is G42 command. Okay. So, this is offset. So, when you look at it, this is the center. So, your first point is here. So, here is your first point. So, the cutter comes in contact with the workpiece, it starts cutting. So, from here the center is moved here and this is your offset diameter. So, and when it comes here, so if you look at it, if it exactly stops here, so then it will try to cut inside the material. So, in order to avoid this, what we do is we offset this by a diameter, by half of the diameter, move to the extreme out and then from here. So, your point should be 1 here, shifted from, that means to the tip must touch here. So, the center must be shifted. So, this is your point 2, then comes your point 3, then goes to your point 4, then you see here you will move along this point 5. So, point 5 also you see here there is a taper which is there. So, what we do is we try to define up to this point 5 and then the cutter starts moving along this line and goes here. So, this is nothing but cutter radius compensation G42. We said G41, G42. This is cutter compensation G42 code for the outer. When we see a canned cycle, A CAN cycle or a fixed cycle are G codes used to combine a number of common motions that are used with some type of operation such as drilling of a hole. So, from here rapidly it comes to this plane, and this plane is called as a clearance plane, and from here you can keep going inside and outside. So, number of times it can peck and then do the operation. So, if you put that in a code form N0 and then G81 X, Y, Z reference plane, you can define the number of times it has to go, and then it also tries to tell what will be the projection of this outside the workpiece also can be defined. So, this is how a CAN cycle works. The various CAN cycles and their numbers are given for your understanding. Let us take only one. So, let us take G81, which is a feed from the surface is going to be constant. So, there is no dwell, the spindle speed will be the same. When it is returning back, it will have a rapid speed. All the drilling cycles and center drilling will use it. Let us look at tapping G85. The feed from the surface will be constant. At programmed depth, end of the feed point, there will not be any action. So, there will not be reversing, the feed rate return motion will be there. This is a tapping cycle. So, this is how a CAN cycle works. Thank you.